So chapter 3 we did transformations. They were rotations, reflections, and translations, right? We moved things around, we turned them around, we flipped them around, those kind of things. The one transformation we did not cover in chapter 3 is dilations. And a dilation is simply a shrinking or an expansion of a figure or an object, whatever. So, and there's a center of dilation which they're going to identify when they're just giving you a specific drawing like this. Its center of dilation is P. Everything is based on P's position in relation to the points on the figure. So what we're trying to do here is dilate a triangle ABC by a scale factor of 1/2 with a center of dilation P. So what we're going to create is a figure, a triangle that's going to be half as big as the current triangle, but it's going to be related to this point P. And the way we're going to do it, begin by drawing a dashed line from P to A. So just take your ruler and draw a dashed line from P to A. Like so. And then repeat that for P to B and P to C. Be as precise as possible when you do this. The images of each of these points will lie along these lines. And I'm only stopping at A, B, and C because my scale factor is less than 1. So my images will go towards the center of dilation. If the scale factor was larger than 1, the points would go away from, so we need to extend those lines further out. And what I want to do is I want to get my straight edge and I want to measure, and I think measuring in centimeters is better than inches. It's a little more accurate. So if we take our rulers out and we measure these dashed lines, my measurements will not be the same as your measurements because our scales are different. But if you take your ruler and measure PA, so position your 0 at point P and then straighten it up to point A and see where it goes to. Mine, it's, A is going 9.7, looks like 9.7 centimeters. So PA equals 9.7 centimeters, which means that PA prime, we're doing a scale factor of 1/2. I want to go half as far. So 1/2 of 9.7 for me is 4.85. And whatever your measurement was, you'd go half of that measurement. All right. So I look on my ruler and find 4.85 centimeters, which is right here. And that's where point A prime is going to go. Kind of envisioning that the shape's going to be a shrunken down version of that, but the angle should remain the same. So I'm kind of putting A prime in a position where I'm not going to have to draw a line through it. All right, I do the same thing for PB and PC. So again, I take my ruler, I position 0 at P, and I come up to B, and I measure that. I'm getting a measurement of, looks like 12.2 centimeters for PB. So PB prime is going to be half of that, which is 6.1 centimeters. So position a dot at 6.1 centimeters. That's going to be prime. And then finally, I do the same thing for point C. Position my ruler at 0 on P. Turn my ruler so it's going towards C. And I get exactly 15 centimeters there. So PC is equal to 15 centimeters. Which means PC prime gives me half of that, which is 7.5 centimeters. Once I've drawn all three vertices of the polygon I'm trying to dilate, then I just connect the dots, A prime, B prime, and C prime, to create this half scale factor version of ABC. So it's just a matter of lining up my ruler properly and connecting the dots. So connect A to B, A prime to B prime, I should say. And then B prime to C prime. Finally, C prime to A prime. If you want to do a quick check to see that it was done correctly, all we have to do is verify that side AB is twice as big as side A prime, B prime, and so on and so forth. So if you were to measure these sides, let's just, it doesn't matter which side you take, I'll just take AB, maybe. There we go. I put my rulers 0 on A, wrapped around to B here. AB is 5.2 centimeters. So I'd expect A prime, B prime, this is 5.2 centimeters. And again, my measurements aren't the same as your measurements. If that's 5.2 centimeters, I'd expect A prime, B prime to be 2.6 centimeters. So if I bring my ruler over and measure it, I can see that it is 2.6 centimeters. So, you know, that's kind of verifies that we did it correctly. So just a quick check to see that you did. If you want to be more secure in your answer, you can check all three sides. I think it's easier to use the ruler by hand than it is to use the one on my board. But again, if you just verify that the sides of the image are half as big as the pre-image, because the scale factor is a half. When we're looking at dilation, just so this is a very good demonstration of what one is, the dilation itself should be a similar figure to the previous figure. So similar means that all the sides are some either shrunken or expanded version of the original side. So the sides get bigger or smaller, but they have a common ratio. The scale factor is what that is. All the angles should be exactly the same. So angle BAC should match angle BAC. So like that, if I got a protractor to verify on this one. And keep in mind, there is experimental error, so it might be off by a smidge, but they should be pretty close. If you had some computer program doing it properly, then we'd probably be more accurate, but we'll see. So if I'm measuring this angle here, it's almost a right angle, doesn't it? So it's almost a right angle. If I come over here to the original, it is a right angle. So, you know, it's off by just a tiny, tiny bit, but it's pretty close to being dead on perfect. So, you know, that's kind of what you're looking for there for these. So the angle measures remain consistent, all these the same, but the sides are either shrunken or expanded by a common ratio.